Swayam Prabha. Digital India. Educated India.
Welcome back. So this was the last slide we discussed in the previous lecture, talking about some signatures from Chile. Now let's see a few more examples from Palu tsunami as well as from Andaman, what we gather, and what are the signatures one can look for if need to identify the ancient tsunami signatures. And at the end, considering all this information, we will be giving you one lecture on particularly how we can model it and what are all parameters, because this is one of the important parameters we have taken into consideration for calculating the tsunami rupture area as well as the energy conditions which we discussed in the previous slides regarding either the water depth or so. But for us it was very important to understand that if such signatures have been seen in Andaman, then what will be the effect on the east coast and as well as in the Andaman area. So that was our main aim, to do that exercise, which we will share with you in the next lecture or towards the end of this course. So in total, what the hazard is or people are at risk because of this hazard is mainly the water height or the wave height which is created by tsunami, because it may, as we have discussed, that it may go up to 30 meters also in some locations, but of course it will depend upon the geomorphic configuration of the coastal areas. And not only that, the rupture area, how much is the rupture area will decide the energy conditions, and another one is what we were talking about, the directivity. So the location, how close and in what direction, at what angle our location of or the site of interest is located, depending on that we will see the damage pattern and all that. Or we can't say at that well, of course there will be a damage, but if we are sitting close to the coast without having proper understanding that what could be wave heights during a particular tsunami, then we are definitely putting ourselves on risk, and that will be the hazardous to us actually. So what has been shown here is that typically the water heights or the wave heights at the time of the tsunami of 2004. Now one can do very easily if we have more of the stations, the gauging stations, which can help us in terms of issuing the early warning. This is just to have in comparison, because in last like 5 years or 6 years we had in two large magnitude or mega earthquakes along the subduction zone. One was in 2004 Sumatra Andaman with 9.1 or 9.3 you can take, and this one was 9 magnitude earthquake or 9.1 of Tohoku, Japan, 2011. So the comparison what has been done here is that what was the rupture length which was observed and recorded at the time of the 1960 Chilean earthquake. The rupture length was around 1000 meters, whereas with the 9 magnitude earthquake of 2011 Tohoku, Japan, the rupture length was around 500 meters, which is almost half than this one. And then 9.1 earthquake or 9.3 you take, you had 2004, that was Sumatra Andaman earthquake. Now, as I told in the previous slide, that this is extremely important for us to understand that what will be the wave heights and the energy conditions of the velocity of the tsunami depending on the rupture length. So if you look at of course this was quite devastating, but the rupture length here, even with the magnitude less than 9 as compared to this one, that is 9.5 and this is 9.1, the rupture length was almost like 1300 kilometers. So scientists suggest that probably this was because of the triggered earthquakes in the next segments, and those segments were been also ruptured and resulted into the 1300 long rupture length. Whereas here the magnitude was 9, the rupture was not so high, but the effect of the tsunami was very unusual, and this they have correlated or with the tsunamis which have happened in the past with the less rupture length, but they have suggested and they to some extent have proved that this was because of the submarine huge landslide. So submarine landslide was responsible for the unusual tsunami effect. So there are now in India also, in Indian Ocean, we have the bottom pressure gauges, as well as we have that there is a whole system which has been termed as DART, DART, is a Deep Ocean Assessment and Reporting Tsunami. So we have now in Indian Ocean, which has been handled by Indian National Center for Ocean Information Services by Ministry of Earth Science, is located in Hyderabad, known as INCOIS. So this institution or organization is having their own system of issuing, that is what we call early warning system. So usually this whole configuration runs like this, and immediately the information has been sent to the respective centers, as well as we will be getting the information even at the tidal levels because of that. So as soon as the earthquake has been triggered, so the system starts sending the information to the respective organizations. So this is one how it looks like. This is the buoy which has been placed, and if you see the distribution, so particularly in like the Pacific Ring of Fire, so people, the countries who are having like this type of events visited very regularly, like US and Japan and all that, they are having multiple stations. But India right now, of course, we have two, but I am quite confident that the INCOIS is having much more data points over here, or the buoys which are been sitting there for the warning system. So this is how it works, the tsunami warning system in total. So like this is an elements for tsunami resilient society. If you want to go ahead with this and to reduce the hazard or to assess the hazard, we need to educate the system. So this is basically extreme most important. So in US or in Japan and in other countries, what they have done is that they have built a platform as in how to educate the people about the hazard and how to minimize it. That is very important. Okay, so the main aim is to educate and to reduce the disaster risk actually. So this is how you can make your the tsunami resilient society. So starts from the basic in the awareness mainly, and that can be done at the grassroots level. So you can do in the schools. So for kids, what they have done, they have prepared the cartoons and the booklets and videos which can help us in with their understanding that how they can make sure that such warning is been issued, so they will. So mock drills have been done and all that, and in villages also they do the awareness camping and all that. Okay, so mainly what we would say that the outreach programs should be done. Then this information mainly depends. For in case of our country, we have different type of hazards. So depending on that, one can design the information brochures, or they can have an outreach programs and do it. In the coastal areas, those who are staying in the coastal areas, for them it will be extremely important. So it goes to the, for in case of the tsunami mainly, so it goes to the coastal community residents, then and along with that, okay, to, reaching this point, that is the final evacuation, all that, tsunami warning system works in, so seismic observation from different points they will gather, as well as the sea level observation from the tidal gauge, and then combining this two information, which is coming from the DART system as well as from the tidal gauge system, the warning or the information goes to the center, and then they will issue the warning. So this is in case of Japan, that what they are having, that they are having different system like us. In India, we will have INCOIS. So INCOIL will give this information to the coastal residents, and then they will decide the evacuation plan. But before getting into this, that this is very commonly done at the grassroots level, which is constant process need to be done, because this will happen or get activated when there is an event. Again, this part, that is hazard mitigation, preparation of the hazard map, and then putting tsunami signs, that is for evacuation, which place or location will be the safest in case of when the warning is issued. People should know about it, okay, the signboards. Likewise, we are aware about the signboards while driving. So these are also, this evacuation signs will be available in nearby areas where they have located the best place to save yourself and move to the high grounds. That will again based on the map which you have prepared, that what is the expected inundation if such a type of event, like I am talking about the event in terms of the magnitude and the energy will be triggered. So what will be the height during that event, and how much ground or the area in the coastal region will get inundated, and which are the locations where you can move, that is on the higher ground. So the mitigation part will depend on completely on the understanding of the past tsunami events. So here what we were talking about, the tsunami deposits and identifying the energy conditions, all that will be helpful. So this is a complete process where the aim is to have the tsunami resilience society and to reduce mainly the tsunami disaster risk. So now India, this we have we all know that from all sides we have been cordoned by the hazardous zones, like one is in Himalaya, in the north, in the east, of course. In this area is also in part of the Himalayan deformation, and then we are having an Andaman here, and then in this side, if we look at, we have Kutch, and then we have Makran subduction zone. So we know that this area is capable of triggering the tsunami because of its setting, mainly the subduction zone, and we are having it. So what usually happens during such mega earthquakes, this was the best lesson to learn after 2004. So this photograph which we took is from the west side of the coast of Andaman, where the west side of the coast uplifted. So if you take an Andaman island like this, okay, and then you move further down, having the Car Nicobar and all that, and then you go down to the Pandache. So you have this Andaman islands of east and west. So west side got uplifted, and some places in most of the eastern side got subsided. So this was very clear signatures which we observed during our survey. So this is the example of a small island which got uplifted on the west coast. Now such observations are very much important to be recorded, because this will affect the day-to-day life in the region, as well as the coastal habitat will also be affected. So aquatic life will get affected, as well as the vessels which are coming in through the ocean route and all that should also need this information. So mainly the Coast Guard or the Navy and any commercial vessels which are traveling or getting into this area should require that what will be the water depths. So water depths mainly changed after the 2004 Sumatra Andaman earthquake. Now this I will quickly share what we observed and what was the aim of conducting this reconnaissance survey immediately after 2004 Sumatra Andaman earthquake. The team has been listed here. We were a couple of us were from civil engineering department at that time, and then we had some officers, Lieutenant Colonel Sodhi and Santosh from Army, who were doing their PhD MTech here at the Department of Civil Engineering, and of course now they might have been placed at very high rank. So we had a very big team from civil engineering, some Professors Murthy Jain, Professor Durgesh Rai, and then people from the industry also joined, Alpa and Arvind, and we conducted a very quick survey for a couple of days. So teams were distributed and we covered almost the entire patch of Andaman and Nicobar, right from north to south. So quickly we can look at that what happened in this area, and then what was the effect to some extent here, but I am not going to talk about this one, but I am mostly of this area. So Andaman is in very ideal condition, has a very ideal tectonic setting to trigger large magnitude or mega earthquakes along the subduction zone, and this is again we can justify having the understanding from the past events. So this is the configuration here. So the Banda Aceh and or you can say the Sumatra area, Indonesia is sitting here, the islands, and then we have a very smaller islands. So this is the southernmost tip of India, which goes smaller island, and then we have the bigger Andaman island. So this is the whole island chain, and 2004 earthquake was triggered here, and it started its journey in terms of the rupturing, and it went right to the tip of this one. So almost 1300 kilometer rupture was there, and the effects which we saw was really dramatic. So even in the past in this area, there were earthquakes which took this region or were 7.5, 7.9, 7.7, and they were in 1800 and 1941. Apart from this, there was another event which was triggered here, was in 1668 or so. So 1668 or maybe around 1672. So there was another event in this area. Now talking particularly about the events related deformation, that is 2004, then what we observed was that the southernmost tip of the India subsided by almost 3 meters. So blue numbers which you see here is indicative of the land has gone down, subsided. So if I just put this here, so this is a land area and this is an ocean area, and the ocean water depth is around here. So this we can say MSL. Now when we say this area subsided, then what is happening is that you are subsiding this area. So I will draw the same profile here. So water level has remained the same, the MSL remained the same, but this area has gone down, so it subsided. So in ultimately what will happen, that this area that is the near coast area will get affected, because this will start getting inundated. And similar example I discussed in for 1960 Chilean earthquake. So what we saw was the maximum subsidence here. It reduced this side, went right up to 1 meter. Port Blair also subsided by 1 meter, and the western side, okay, west side got uplifted. So basically it was like this got tilted. Okay, so this area was uplifted, this subsided. So it was a push from the side, because if you see the configuration here, then what we have, this is the trench area. So the deformation is between those two plates. Okay, so this is overriding, and this plate is going below at this juncture. So if I put the cross section, then it will come like something like this actually. So this is overriding. So this portion slipped, and this of course moved towards it. So push was, so this resulted into the tilt of the Andaman, which is sitting over here. So it tilted, this area subsided, this got uplifted here. So coming to this, like what we see here is basically we have the subsidence, and we have an uplift which went up to 1.3 meter. And just for the Andaman Island, collecting all the information, what we plotted was that this was the zero line here. This is pivotal line along which the tilt was took place. So this part went up and this part went down, and in this area there was no effect. So it just rolled over. Okay, so the rolling effect was been seen here. So this side it was around 1.3 meters, and then we have the displacement, or we can say this subsidence related to displacement was almost like 1 meter. So this is the past records. We are having like couple of earthquakes which were been reported by the Britishers. At this period, the Britishers occupied this area, and of course in 1940 or 45, Japanese also occupied this region. And this picture, again the sketch, it comes from the one of the publication which was done in 1884 by Oldham, which talks about that the local tribe in that area which survived. Even during 2004, this tribe, the people from this tribe survived, and because they understood well about the what we can say the storm surge, but this was not storm surge, but this was a tsunami. But they understand that what best they can do at the time of any surge, either it is a tsunami wave or it is a storm surge. Okay. So their construction is typical, that they construct their houses, the circular house here, okay, and then floor sits at a few meter above the water level. So if there is a tsunami and they understand that what will be the height, then the tsunami waves pass through this one, and if since you are having this circular columns here of wooden columns, then it will disseminate the energy also. So they are safely sitting above the water. So this is another very important aspect, that how people who understand the phenomena or the process makes themselves safe, or they reduce the risk from a particular hazard. Now if you look at this is a model which was been prepared by Kinji Satake from Earthquake Research Institute, University of Tokyo, which shows that this was the whole front which got ruptured, and then the tsunami waves got generated, and what probably the height, but it was not very particular. But one thing which came out very interesting was that we got enough time for this portion to receive the tsunami waves. It's almost like around 300 minutes or so. So if I play it again, you just watch it, that how it originated, and it was not just that this area got affected, but the regions surrounding the Indian Ocean were affected, and that's what you must have watched the some videos which are available on social media, that what was the effect on the Thailand side and what was the effect, of course, in the Indonesian side, and the cities which were sitting close to the east, along the east coast. So the another worry which is coming, of course, is that we need to and of course so far I know that INCOIS has already generated the inundation maps along this coast in the east side, and also taken care that what will be the inundation of the area during a particular event of the particular energy of and then what will be the effect of that to the local people, and as well as to the nuclear power plants which exist today and which are supposed to come in near future. So if you take this, then you will understand that how much time it almost took to reach almost 20 minutes it took to reach the Indian coast. So we had enough time to announce and we had enough time to issue an early warning system and enough time to implement the evacuation plan, but none of this were with us. We were not having any early warning system with us. We were not even aware of that what will be the effect to the coastal region and how we should have planned the evacuation. So nothing was there with us because we did not even thought of that this type of event will occur. Still we tried to underestimate most of the things, but I hope that whatever the research we have been doing and whatever the information we have generated, the higher authorities, or we can say the organizations or the institutions or the ministry should take this in they should consider seriously and they should re-evaluate if there is something missing out of this. Okay, and recent research we identified almost 7 tsunamis from one single location, and also we are pretty sure that they will be having different effect if similar type of events have been triggered in this region. So let's see quickly the uplift and subsidence from this region related to 2004. So I'll quickly go through. So you have having the Great Nicobar, the subsidence was around 3 meters. So this was a photograph which was been taken before by Coast Guard, where you can see the huts sitting here, but immediately after that, that is 2004 tsunami, it is completely wiped off. The beach has moved inside. So this is because of the land subsidence, but the whole area was completely wiped off and eroded this one. So you are having now the beach which was sitting here is now sitting at the back. Similarly was the case in the Car Nicobar, in Great Nicobar only. In another region the area remained underwater because of the subsidence. So these are the photographs of the Coast Guard office, which are the headquarters in Campbell Bay, and it's Great Nicobar, where they have the experience that the water never used to enter into their premises, but now it enters during during high tides. Okay. And this is the photograph or the which I want to show that this island also got subsided, and because of that, because the height is not so much, what we see now is that these are divided into 2 different islands, and that was because of, and this area we also we were able to see some drowned coastlines, which were like, this is an older coastline here, okay, drowned shoreline, and this one here, so shoreline which got subsided in 2004. Trinket Island, and these are the pictures, the images, IRS images which were been taken before and after, so pre-event, post-event. So this what happened, but we got this images later on, but when we flew across this area, what we found was that yes, of course, this area got subsided, and because of its less height, now the water is flowing through and through across this one. Coming to Car Nicobar, the height of this island, the elevation maximum goes up to 70 to 80 meters. So it is a very flat, almost flat island, and beautiful beach areas and the coastal environment. So this whole area got affected, and this was the residential area of the Army and Indian Air Force. So you have the runway which was long back constructed by Japanese people, but now it is with us. So this area was occupied by the Indian Air Force and the Army people, which was completely wiped off because of the 2004 tsunami and the earthquake. This is what happened, and most sad part was that this event was on 26th morning, and 25th was the Christmas Eve. So everybody enjoyed late night, and they in morning they faced this event. So many people got killed from this region because of their unawareness mainly. This again, it's showing the inspection bungalow, which used to have almost 100-meter wide beach, but now it sits in water during high tide. That is because of the subsidence. So you can look at that. This was the height, almost like 7 meter, which toppled most of the top of the houses, and the return waves you can see with the hanging clothes and on the window grill. So and then the inundation of the water, which was almost around 600 meters inland from the coast, was around 3.5 meters. So I'll stop here, and then we'll continue in the next lecture. Thank you.